Hello, ladies and gentlemen. We are now on to our second day of logarithms, and this one focuses primarily on the properties of logarithms. Okay, what rules can we do when we see a logarithm? We know how to convert it and change it from exponential to logarithm, but actually understanding what can we do when we have a logarithm. So first off, what is very important to understand is that logarithms are related to exponents. It's a form of exponents. That's why we're allowed to convert between the two. So since it's a form of exponents, all of our rules of exponents are going to apply. So therefore, we must fully understand what are our rules of exponents. So our first rule of exponents is that if I have the same base, we're allowed to add the exponents. So for example, if I have x to the third power times x squared, this is like my favorite one to use, we go ahead and add those exponents and we should get x to the fifth. The next rule that you see is division. If we divide, then we subtract our exponents. So for example, a to the fourth over a squared is the same as a squared. 4 minus 2 is 2. And then of course our last rule is exponent to exponent we multiply. So if I have an x to the third raised to the power of 2, then I multiply and get x to the sixth. So that should seem fairly basic. We've done it a couple of thousand times. So let's now talk about the rules of logarithms. They overlap in some way. So in the first one, we say that if I have m times n, that's the same as adding. Very similar to the top. We said if we are multiplying, we add their exponents. So here's an example. If I have log base 2 of 3 plus log base 2 of 5, I can rewrite that as log base 2, and of course they have the same base. That's very important that they all have b's. They all have base 2. I can take 3 and multiply it by 5, which simplifies my answer to log base 2 of 15. We're allowed to do that. We're allowed to bring them together and multiply them. Again, going back to the rules of exponents. Our next one says that if we divide, we're actually subtracting. Again, the same as exponents. If we divide, we subtract our exponents. So what we're going to have here, if I do an example, let's say I have log base 2 of 8 minus log base 2 of 2. I can rewrite that as log base 2 of 8 divided by 2, and therefore I get log base 2 of 4. Makes sense? And then the last one says that if I have log base b of n raised to another exponent, we're allowed to kind of pull that exponent out front. Now this is a little different than the rules up top, but if we were to convert it, you kind of see how it all plays out. So what I'm going to do is actually it backwards. So I'm going to do an example like 3 log base 2 of 2. I can rewrite that as log base 2 of 2 raised to the power of 3, which is the same as log base 2 of 8. Now, where are we going to actually use this? Again, I put in there, don't rush, guys. It's better to take your time. Is going to be expanding and condensing. Expanding means making it longer. So for this very first example, I'm going to have log base 10. Now, this is multiplication. So if you look back up at the very first rule, we are allowed to split that up, the a and the b, and make that log base 10 of a plus log base 10 of b. Again, they both should get the 10. Don't leave that out. The 10 doesn't matter as much, but when you start getting over here into the a's, it's very important to actually say what is your base. Now this one's division, so you can actually see here's a subtraction sign. It's going to be subtraction log base a of y. And then the last one would just be pulling that out in front. Now what gets really exciting is when they start getting a little more of everything, right? So here's one that has exponents and it has multiplication. So what I would recommend is dealing with the multiplication first and splitting that up into an addition sign. So if you remember, multiplication becomes addition. Once you do that, always save the exponents for last. It just kind of makes your life easier because they each have different exponents. So wait to pull them out in front. Always do the exponents last. Oops, I know why that should be a plus sign. 3 log base 6 of y. So with this one, again, what you basically have here is 8 times x to the fourth, right? And according to multiplication, we can split that up and make that addition. Once you split it up and make addition, now you can pull that exponent out in front, and it only goes to the log. Again, I did the equal sign. Make that a plus. It only goes to the log base 2 of x. It doesn't go with the one with the 8. Don't put it out in front of everything, just put it out in front of its own. And then this last one, probably my favorite of the day, is fun because here's subtraction, so I know I should be doing subtraction. So I'm going to get log base 3 of 5x squared minus log base 3 of 9y. And here's where that whole don't rush comes in. Take each piece at a time and say, okay, I'm going to deal with this piece first. I'm going to make that log base 3 of 5 plus log base 3 of x squared. Then as far as the subtraction goes, and frequently people just kind of group it together because you are subtracting this whole thing, right? So I'm going to subtract a log base 3 of 9. Now this is multiplication within here. This is multiplication. So I'm going to make that addition for now. But I stress for now because ultimately both of these pieces will be getting subtracted. So if I go ahead and deal with these exponents, right, that's going to become log base 3 of 5 plus, pull that exponent out in front, 2 log base 3 of x. And then this last piece, like I said, you are subtracting this whole thing. So when I change this whole thing into this piece right here, I am going to be subtracting a log base 3 of 9 and subtracting a log base 3 of y. So they both become minus. That minus sign goes to the 9 and to the y. So keep that in mind with expanding. Now expanding, as you can tell, is a very long process. On the bright side, the last thing that we end with down here is condensing, which is not as bad. Is not as bad, I promise. So basically, you see addition, and I actually kind of see, when you look at addition, you can kind of rotate it sideways, and you'll see it becomes multiplication. That's what happens with logs. So this is going to become log base 2 of 13 times 3. So if I figure out 13 times 3, you can change that into a log base 2 of 39 and simplify. That is much shorter than writing out this every single time. Henceforth, the word condensing and making it shorter. Now this problem over here has a 7 out in front, so we're going to make that 7 and we're going to move it back behind. So previously we would take that 7 and move it out in front if it was an exponent. Now we're putting it back as the exponent. And then I'll do one more with you guys just to kind of wrap it up as, well, we can do 2 more. We'll do 2 more. Some of these get very tricky. So again, kind of recommending reverse like this one. Move the exponent first. So if you remember on the previous page, we always said save the exponents for last. When you're condensing, you do it the other way around. Move the exponent first. So if I move that exponent, it's going to become log base 10 of x squared. And then deal with the subtraction, which says I'm going to be doing division. Now, if you recall, in your final answer, and this is very important, in your final answer, every single condensing problem only gets 1 log. So if you look back up at the ones where we expanded, right, each of these only started with 1 log and ended up with multiple logs. So expanding says you're going to create multiple logs versus condensing, you only get 1 log. Now, the big one that I want to go over is going to be problem, it's not numbered, but this problem over here. So if I end with this problem, again, always start with the exponents when condensing. So I'm going to make that log base 10 of 6 minus log base 10 of 1 over 3 to the third. 1 over 3 to the third, I can go ahead and simplify that right off the bat to become 1 over 27. Just makes my life a little bit easier when I decide to convert this to division, because again, here's the subtraction bar. Think of the subtraction bar as like division, right? So you're going to get log base 10 of 6 over 1 over 26. And here's why I wanted to do this problem. This 6 divided by 1 over 26 is the same as taking 6 and multiplying it by the reciprocal, which is 27. So you're actually going to get a 162 in there. So hopefully that kind of gives you a gist. If I give you some hints on the other ones, move the exponent first and then think addition becomes multiplication. You can kind of see it rotate. You see it rotate and turn into a multiplication sign. If it's a subtraction problem, that's where you're going to get that division. Now you'll notice it's in parentheses here because that whole thing will go on the bottom. So if I convert that first and say, okay, addition becomes multiplication, that's 4y. Don't forget about that 3 moves. So now what I have is log base 2 of x to the third and minus log base 2 of 4y. That minus says I'm going to be doing division. So I'm going to have x to the third divided by a 4y. And again, making sure that your answer only has one log. It's not like the top gets a log and the bottom gets a log. It all gets one single log in your answer. If I see 2 logs in your answer, you did something wrong. Condensing says you should only get 1 log. And honestly, there's a couple people out there that think of these problems as more like, hey, I'm going to write the log first and then figure out what's happening behind it, right? And they're like, okay, well, that's going to become x to the third. The minus sign says I'm doing division. And then I have a 4 plus y that says multiplication. That's what's going on inside. So some people actually just write the log first. That way they don't have to really worry about the log. And they simply figure out, okay, what does the subtraction mean? What does the addition mean? Honestly, the best way to learn this is through practice. So you have some homework tonight using these practice. Just really focus on these conversion rules, both directions. If you're going from this to this, that's expanding. And if you're going from this to this, it's condensing because it's making it shorter. So long to short is condensing, short to fat is expanding. All right, good luck.